Last class we have finished basic introduction to oblique drawings. So, we have covered one examples and steps. So, just for a repeat, step 1, draw a rectangle overall width and height of the object, step 1, because the front face is giving your true shape. Extend parallel lines from each corner of the back box at an angle. Mark extension lines at a point equal to depth of the object. Connect the depth of the lines to form the box, step 4. All steps, step 1, step 2, step 3, step 4, step 5. Add any details such as holes, notches in the front view. Then step 6 and 7, extend the details, the depth of the object. Then obviously, once you finish it, complete sketch by darkening in the object. This example I have finished, these two examples I have finished. Take your reference line, reference point, then width, mark your width, mark your depth, then mark your height, then in depth directions make an angle with 30 degree. This is your depth directions, this is your depth direction, this is width, this is your width, this is your height, this is your depth directions. Then as front view, it is in true shape. So, whatever the dimensions, distance from here to here, distance from here to here, this is in true shape. So, take the measurement and do the distance, this is your height, this is your width, finish it, then mark your center line, and take the measurement of your R1 and take measurement of R2, then draw circle, semicircle, R1 and R2, draw the semicircle, inner circle as well as outer circle. Then once it is over, in the depth direction extend it. Depth directions, this has been drawn at an angle 30 degree, right up. So, this is a depth, this measurement you can get it, you can take in depth directions. Similarly, at top, at the height depth direction you finish it up. Then once you finish it up your dimensions, depth, height and width in depth direction, then finish your same procedure as far as this front view, front part, whatever you have drawn in the rear side or back side, finish both the circles, both these semicircles, outer as well as inner. This is your outer, then go for inner one, this is inner one, then this completes front as well as rear sides. Then you have to join, then look at how the object looks like. I joined with a common tangent between these two, then how the object looks like. If you look at here, these are the parts I am not going to see, that means this is not going to visualize. So, this part, then you can erase it, after you erase it, then darken complete figure. This is your oblique drawing for this case. Similarly, second example 1, 30 degree to the right and up, I have also covered just for a repetitions. Mark your reference point, then width, then height, then 30 degree to your depth directions, 30 degree to your depth direction, then locate with your reference point, locate your center point or center line here and here it is circle, then here you locate it. How do you locate it? How far from here to here and what is the distance? How far from here to here and what is the distance? Then draw your once you locate your center line, center of the circle, then draw the circle. Similarly, in the depth direction, go towards the depth, you can take the measurement of the depth, this is your depth. So, in this direction take the measurement of the depth, then again locate your center of the circle, then draw the circle. This is the feature, inside feature, then join by means of common tangent, then finish your outer surface by taking the measurement in depth as well as width as well as in height directions. Then finish it off. After finishing it off, take a call how it looks like. Look at here how it looks like. Before this step, this is what you have drawn, inside as well as outside features, because this is in the front face or this is your front view. So, front face will be true shape. So, that means then you have to erase certain part where you cannot see it. Look at here, this line, this line, this line and this circle, it cannot be shown or I cannot visualize because it is the inside feature. So, to finish your inside circle, then you remove it, this comes your object, oblique drawing. Circles and arcs in oblique drawings, orthographic views, then oblique drawing, how it looks for visualizations. This is your orthographic view, front view as well as side view, then oblique drawing, how it looks. Object orientation for oblique, B, C, A. Look at the same object, how it has been oriented, A, B and C. The greater distortion at B and C than A. First you identify where is your distortion, in which direction there is a greater distortion. In B, if I make it in B, make it oriented so that this is C and this is A. If I compare A, B, C, then the greater distortion at B and C than A. Place the object with the irregular outline or contour parallel to picture plane. Irregular outlines or contours should be parallel to picture plane. Number 2, note the exaggerated depth at B. This is your B, this is your A. In case of A and B, this is coming as a width. In case of B, the depth direction is long. The depth direction is long. In that case, rule 2, the longest dimension should be parallel to the picture plane. Longest dimension should be parallel to the picture plane. In this case, this is your shortest dimension, this is your longest dimensions. So, you cannot put your shortest dimension parallel to your picture plane in B, it is not there. In case of A, this is your longest dimensions. So, you are putting parallel to picture plane, that means you will get the true shape. These are the two rules. Once again, rule 1, place the object with irregular outline, place the object with irregular outline or contour parallel to your picture plane, rule 1. Rule 2, longest dimension should be parallel to the picture plane. So, these are the two rules you have to follow in case of oblique drawing. Then there are two views, one is your cavalier, another is your cabinet oblique views. In cavalier view, front view mark the difference between cavalier and cabinet. In cavalier view, front view true shape, receding axis angle varies, remember this, axis angle it varies 30 degree, 45 degree or 60 degree, 30 degree, 45 degree or 60 degree. Depth dimensions true size, depth dimension it is your true size. Come to your cabinet view, front view true shape, receding axis angle varies 30 degree, 45 degree or 60 degree, depth dimension half size. This is the difference between two view, one is cavalier view, other is your cabinet view. In cabinet view, in depth direction it has been reduced to half, but in cavalier view depth direction it is your true size or true shape, true length, you can say that. Look at how your cavalier oblique view and cabinet oblique view looks like. Same object in the depth directions in cavalier, this is your depth directions, this is your whatever the actual real figure dimension, the same dimension, but here actual dimension of the depth has been reduced to half, actual figure depth dimension has been reduced to half. How this two figure looks like? In depth direction it has been reduced or shortened, in depth direction it is the true shape. So, look at the cabinet projection, the foreshortening of the z axis is increased to provide a more realistic view. In cabinet projections z axis you are reducing, foreshortening. Why? Suppose in z direction there is a larger dimension is there, showing in depth directions. In clear picture if you foreshorten, that means you are bringing back side dimensions towards closure. In depth direction, suppose depth direction is large, suppose in this case this side is your, this is your front face, this is your rear or back face, you can say back face. Suppose in depth directions it is larger, in the back face there are certain features. So, to show it and bring it closer so that you can visualize. So, that is the object behind these cabinet projections. The foreshortening of the z axis is increased to provide a more realistic view in z directions or in depth directions. Oblique drawings, length of z axis. Cavalier, remember 1:1:1, that means it is completely true shape. I am not saying about true shape, completely same length, same dimensions, front face is your true shape. So, 1:1:1, that means width, height and depth 1:1:1, cabinet 1:1:0.5. Remember this is your width, this is your height, this is your depth. So, here cabinet 1:1:1, then 0.5, this is in your depth directions. Look at the two drawings, length of depth axis, one drawing very simple feature, a building, one drawing in the depth axis, it is a large dimensions. So, if you bring back to the front, so back side you can very easily visualize what is there in back side. So, that is the reason this cabinet view or oblique drawing is there. What is the objective of this oblique drawing, particularly your cavalier as well as cabinet? Reduce the size in depth direction so that you can visualize clearly what is there in rear side of this object. Receding axis 45 degree to the left and up. I am sitting here, if I say 45 degree to the left and up in depth directions, that means here 45 degree to the left, this is the left. So, here 45 degree to the left and up, means with a normal axis it is up, 30 degree to the right and down. Remember these notations in the exam, this will be given the notation 30 degree to the right and down, 30 degree to the right from here, 30 degree to the right, here in this direction right and down. Down means with your normal axis it is down to your normal axis. This way it will be given. Kind of the question will be asked, draw a cabinet or cavalier view where your depth direction 30 degree to the right and down. That means, it will be down and 30 degree towards your left. If you look at here 45 degree to the left and up, here is your 30 degree to the right and down. Oblique views, front face selections. Look at your front face selections. I cannot select in this way, this is my front face. Why? Because curved features or more curved features where there are curves, I can see taking into the front face. So, this is the best way. Rule 2, this is your rule 1, contours of irregularity or irregular face or maybe curved faces. Rule 2, longest dimensions, this is your longest dimensions, you put parallel to your picture plane, it should not be in your depth directions. So, in this rule 1 and rule 2, considering these two, this is not a true front face. Oblique drawing example 2, 30 degree to the right and up. Just I am going slightly faster, 30 degree to the right and up. See, this is what is your front view, this is what is your top view. Front view in oblique drawing, this is your true shape. So, then in case of front view, this is your true shape. Now, in the depth direction, it is 30 degree to the right and up, 30 degree to the right and up, 30 degree to the right. From here, if this is my reference point, from here to the right hand side and up. Then you can finish it up in your depth directions. How these objects looks like oblique drawing. Example 3, 30 degree to the right and up, front view as well as top view is given, all the dimensions has been given. If you look at here, this is your width, this is your height and this direction is your depth, because obviously this is your top view, this is your front view. Then if you start it 30 degree to the right and up, if I am taking x and y, this is my reference point, 30 degree to the right from here to right hand side and up, depth directions. This is what how it looks. 90, 65 plus 20. First identify your dimensions. This is your 90, right? This is your width. Height is your 40. Height is 40. Depth is given 50. Start doing this. Front face or front view as it is there in oblique view, it is your true shape. So, whatever the dimensions are there, it is in true shape. Then go to the depth directions, then finish your slanted face. Up to this you finish it off, take it out. Now, what remains? There is a, look at here, there is a circle, divide it, then mark the coordinate, because here it is given, 15, from here to here it is given 15, then here to here it is given 65. So, here to here it is given 50. So, you can find it out what are the coordinates or center line, you can find it out. Once you draw, mark the circle, remove it, how it looks. Certain animation part I have missed, you can look at here, again basic fundamentals of your oblique projections. I am just animated taking this object picture plane as well as front plane. This is your object, this is your picture plane. Parallel to each other, projector lines are perpendicular to your picture plane. How it looks? This is your orthographic projections. Now, look at the object. Now, it has been rotated, means it has been made it down 30 degree. How the object looks? Then again third case, x, it has been making up. This here with your axis up, this your axis down. Look at this object, how it looks, making up and down. Now, here orthographic, object is here, projectors are here parallel and perpendicular to your picture plane. In this case, it has been make 30 degree, some angle of 30 or 45 degree or 60 degree down, here it is up. Then you can look at how the object looks like. Simple animations I have shown. A parallel projection is one where all the lines that are parallel in 3D shape remain parallel when projected. A parallel projection, oblique parallel projections, a parallel projection is one where all the lines that are parallel in 3D space remain parallel when projected. An oblique parallel projection is one where the object in question is viewed from the side. A parallel projection is one where all the lines that are parallel in 3D space remain parallel when projected, An oblique parallel projection is one where the object in question is viewed from the side, unlike the plane parallel projection. The z axis is drawn at some angle, alpha to your x axis. As I said, moving up, moving down, towards left or towards right. This is your oblique parallel projections. This is your front view, slightly complicated case. One example, right side view. Visualize the object, oblique view of an object with oblique surface. This is a typical case, oblique view of an object with oblique surface. Take respective points in your oblique surface, take sections A prime, A double prime, 1, 1 prime, 1 double prime, finish it up here, similarly B and 2, similarly C and 3, similarly D and 4, mark the points. Then draw this oblique projection, oblique view, because if this is your front view, that means this part is in your true shape. So, you can very easily draw it, taking respective points here, you can measure the coordinates, because this is your oblique surface, right. So, take coordinates here, then take measurement, then mark these points, then you can draw this. Once it is over, then go to your depth directions, finish your depth directions. How you are going to finish it off? This is my depth directions. In depth directions, mark 1 1 A, 2 2 B, mark 3 3 C, 4 4. Whatever the drawn, I have drawn it, you mark it both the sides, because if this is AA, this is your AA, this side will be 1 1, because this curved face, oblique surface is continuous. So, once you mark it, Look at this mark. Are you getting all? This is a typical case of oblique view of oblique surface. That means front face you mark it, this is your front view, this is in true shape. Then as you have taken different sections in oblique surface, 1 1 AA, 2 2 BB, 3 3 prime, 3 double prime, C double prime, 4 D. Similarly, you mark your A prime. Here in case of side view, we can mark it, how far it is there. Then 1 2 3 4 here A B C D you can mark it, then join accordingly. Because already in the front face, if you look at here in the front face, already in the front face I have marked 1 2 3 4 5. Similarly, A B C D, 1, this is your 1, this is your 2, this is your 3, this is your 4, this is your 5. So, similarly, this is a 1, 2, 3, 4, 5. So, these points located very easily, taking your width as well as height 1, 2, 3, 4, 5. Then from here you can find it out, because from here to here this is your oblique surface. Here you can mark where is your A is there, A, B, C, then D. Here it is A, B, C and D. How do you get A, B, C and D? From here you can mark your points, how far it is there. Then front view or front face, you can finish it A, B, C, D, 1, 2, 3, 4, 5. From here to here you can join it, by arc or you can join it simply. Then once you finish it up, your front face, then in the depth directions, take 1, 1 prime, 1 double prime. Look at here, 1, 1 prime and 1 double prime, 2, 2 prime, 2 double prime. How to get the 2 prime? If you look at here, this is your case of your side view. With respect to reference, I can get it 1 prime A, 1 prime A prime. How far from the A? 1 A your 1 prime and A prime. How far from your 1 A, 1 prime A prime? How far from 1 A, 1 double prime A double prime? 1 A, that means with respect to 1, what is your 1 prime? With respect to 1, where is your 1 double prime? 1, 1 prime, 1, 1 double prime. You plot all these things, 1, 1 prime, 1 double prime, 2, 2 prime, 2 double prime, 3, 3 prime, 3 double prime, 4, 4 prime, 4 double prime, 5, 5 prime, 5 double prime. Similarly, you finish it off A prime, B prime, C prime, D prime and D double prime. Then join. Then look at how I am joining it. First, how you have joined? You have joined if this is your 0, if this is suppose 0, not O, say it is O. First front face O, A, B, C, D, then 5, right. Then you have to go in the same sequence, O, A prime, B prime, C prime, D prime and 5 prime. Then after 5 it is 5, 4, 3, 2, 1. Here it is 5 prime, 4 prime, 3 prime, 2 prime, 1 prime. Just join the coordinates. How you are joining it? Once you mark this point, from here to here I join, then mark it by smooth hand, from here to here I have joined, here to here I have joined, because this is a curved face, this is one of the curved face. Then similarly next step, 1, suppose this is O, this is O prime, this is O, this is O prime, then 1 prime and O prime, because here earlier 1 O prime was there, you join it. The next step, finish it up, again it will start from here, then go to D double prime, 5 double prime, 4 double prime, 3 double prime, 2 double prime, 1 double prime. Then in depth directions you go. Once you finish it up, you have finished curved surface inside feature of your curved surface, because prime objective of this oblique projection is, if there is a curved feature, that has to be shown clearly in case of oblique projections. So, then this is what, how your front side, this is your front, then this is your rear side, then which part I can see it, exactly which part I can see it. If you look at here, how it looks, I have removed, put it here, extend it, come back. Now, this is my actual object in oblique projections. I request all of you, practice it at your home, taking this example. Once this example is clear to you, everything of your oblique projection will be clear. This is a slightly difficult problem I have solved for your reference. Look at this object, visualize front view and right side view, front view and right side view, visualize this object. This is your oblique surface, this is your oblique surface. Then it is a simple case of oblique view of an object with oblique surface. Front view is given, right side view is given. Then once again I am explaining, take a reference point, reference line, then mark your oblique surface, different sections, mark the points. Then once your front face or front view has been given, in oblique projections, front view is your true shapes. So, finish your front face or front view, because this is your true shape. Then go to your depth directions, then mark the same way, the way the points has been or sectioning has been marked and points has been located. Mark the same way, 1 1 prime, 1 double prime, 2 2 prime, 2 double prime, 3 3 prime, 3 double prime, 4 4 prime, 4 double prime, 5 5 prime, 5 double prime. Finish it off, taking into consideration the way it goes. If it starts from here, how it goes, curved surface 0 or O, A, B, C, D. After D it is coming 5, 5, 4, 3, 2, 1. This is your sequence. So, if you start it same way, I am starting here O, here it is going A, B, C, D, 5, 4, 3, 2, 1, O, A prime, B prime, C prime, D prime, 5 prime. Then similarly you go back from 5 prime to 4 prime, 3 prime, 2 prime, 1 prime, then join it back. Similarly rear face also you finish it up. Now this is what your object, front as well as rear side. Which part actually it looks like? This object looks like, if you look at how the object looks like, it is a curved surface. Remember this part of this object is a curved surface, complete curved surface. That is why your oblique projection is required or oblique view is required. So, how it looks? It looks like this. So, more examples, probably if time permits I will cover your oblique projections or oblique views. Next class I will start sectioning. Thank you.